Hello friends, once again welcome to my channel Surprises of God. In the previous video, you had seen some activities. To go with the next topic, let's revise the previous study in short. We have still studied the physical properties of matter. That matter is made up of particles, and the particles of matter are very small that we cannot see with naked eyes. Characteristics of particles of matter. Particles of matter have space between them, they move continuously, and they attract each other. You also studied the three states of matter, the properties of the matter in each state with respect to compressibility, shape, volume, space among particles, and the force of attraction. You had also learned the topic, the interconversion of the three states of matter, that is fusion, vaporization, deposition, solidification, sublimation, and condensation. Moreover, you studied about latent heat, which is the heat required to change the states of matter. Friends, in this video, you will today learn about relation between units of temperature. The three units are there of temperature, that is degree Celsius, degree Fahrenheit, and Kelvin. You will also learn about effect of change of pressure, evaporation, factors affecting evaporation, and how does evaporation cause cooling. Before going ahead about temperature, let me tell you what is the meaning of unit. Unit is a fixed quantity. With respect to, we measure the other quantities. Temperature is also measured in three different units, that is degree Celsius, degree Fahrenheit, and Kelvin. Remember friends, here along with the Celsius and Fahrenheit, we have to put the symbol that is very small circle to the left head of the letter, that is called degree. Along with the K, we don't write such a degree symbol. Among these three units, Kelvin is the SI unit, that is the unit accepted by the whole world, and in almost the measurements, Kelvin is considered. Now see, we will learn the relation between units of temperature. Here we are going to study about the relation between Celsius and Kelvin. In degree Celsius, the melting point of ice or freezing point of water is 0 degrees Celsius, which on the Kelvin scale has the value 273 Kelvin. So, the relation between Celsius and Kelvin is given as below. To convert Kelvin to degree Celsius, what we should do? So, we have to subtract 273 from given Kelvin. One example is given here. The temperature of hot water is 323 Kelvin. To change this Kelvin into degree Celsius, we have to subtract 273. That what we get here, that is 323 minus 273, that is 50 degrees Celsius. Means the water whose temperature is measured 323 in Kelvin unit, that is measured 50 degrees Celsius in Celsius unit. Now, to convert degree Celsius to Kelvin, we have to do the reverse process. That is, we should add 273 to given Celsius. One more example for the same is explained here. That is, the temperature of water in an earthen pot is 25 degrees Celsius. To change this unit, that is degree Celsius, into Kelvin, we should add, that is what, say 273. So what answer we get? That is 298 Kelvin. What does it mean? The temperature of water, which is measured in degrees Celsius as 25, in Kelvin it is 298. So we will now go with the little exercise, that is what given in the textbook. And here After learning the relation between Kelvin and Celsius, you should solve this first and second question. In the first question, it's given that convert the following temperature to Celsius scale, and you should remember what you should do. To convert from Kelvin to Celsius, you should subtract something. The number you should remember. In the second question, what is the physical state of water at 250 degrees Celsius and 100 degrees Celsius? So the second question, you should remind the previous video study. And in this topic, you studied about the temperature is measured in three different units, the interconversion of degree Celsius to Kelvin and Kelvin to degree Celsius. To go with the process of interchanging of the units, you have to subtract 273 somewhere, where in the other case you have to add 273. To memorize this conversion method, you can go with the letters. Take K for Kelvin, C for Celsius, and subtraction for Kelvin to Celsius. So you should remember the three letters, that is KCS. If you remember, KCS means from Kelvin to Celsius you should subtract 273 is number to number, easy to remember, and in the next go vice versa. Here you should remember first letter of Celsius, Kelvin, and then add. You have to remember three letters only, CKA. C stands for Celsius, K stands for Kelvin, and A stands for add. Again the same number is there, so no more memory you have to use up from your mind. Just remember KCS and CKA. The simple conversion you can do. You may remember this figure from the previous video. This is gaseous state, this is liquid, and then the next is solid state of the matter. Here in gaseous state, we know that the spaces among the particles is much more. And now if we reduce the space, what may happen? Can we reach up to the condition of liquid, where the spaces are lesser compared to that of gases? And if we apply further force on the liquid, can we reach up to this? To these questions is here that what we are going to study, effect of change of pressure. What may happen when pressure is increased or decreased on any particular type of matter in its particular state. On applying pressure, the particles of matter come together and a stage can come that the matter in gaseous state can change into liquid state. In the previous video, we had learned about the effect of temperature on the matter. The increase in temperature can change the state of matter. Now we are going to see the effect of pressure. Here in the figure you can see that in the first three figures are shown. In first figure the cylinder is filled with gas and a piston is just left without pressure. When the pressure force is applied on the piston, the pressure is exerted on the gas which is there inside the cylinder, and you can see in the second figure the particles have come together, and in the third the piston is pushed more. Then when more force is applied, the pressure exerted on the particles of gas is more, and we can see that the particles have come together further. In the last video we had studied about these properties of solids, liquids and gases, and as we know that spaces among gases are much more that among the liquids in the above figure is lesser than that, and in the solids it is less. So when the particles of gas are brought together, they reach up to the level of the liquid. So when much more pressure is applied on the gaseous state, the particles come together and the gas can convert to the liquid state. Friends, have you seen this symbol? It shows the gas cylinder. It is the LPG gas cylinder. It stands for liquefied petroleum gas. And why it is called so? Because what we have studied now, that on applying pressure the particles of matter come together and a stage can come that this gaseous state can convert into liquid state. And here the petroleum gas, which is one product of petroleum, even it is obtained in the form of gas, it is filled in the cylinder at high pressure, and so it converts to the liquid form. When the gas is released into air, when we open the regulator at the low pressure, the pressure is reduced because we are opening it to the atmosphere, and since it is filled at high pressure, it is in liquid form. This liquid formed gas at low pressure is converting back to the gaseous state, and we use it in the kitchen. Example of the same is dry ice. Dry ice, why it is called dry ice? Because it is not giving any liquid. It is the form of carbon dioxide. When carbon dioxide is stored at very high pressure, the gaseous form of carbon dioxide turns to liquid and then to solid form. When this solid form of carbon dioxide is left open into the air, atmospheric pressure, the solid carbon dioxide directly converts to the gaseous state without coming into liquid form, and that is the reason why it is called dry ice. You might have seen some experiments on YouTube of dry ice. Friends, let's revise a bit how the pressure affects to the state of matter. As the pressure is increased, the state of matter can change from gaseous to liquid and liquid to solid, and vice versa. When pressure is reduced, the solid form can convert to the liquid and liquid form can convert to the gases. And here again you are having the questions. The third question from the same exercise: for any substance, why does the temperature remain constant during the change of state? There you should remember the very important definition. Friends, again I will remind you that I will give the hint and not the answers. The fourth question, that is depending on the last topic what we have just now studied, suggest a method to liquefy atmospheric gases, and you can remember the LPG. You will get answer simply from this. Friends, now let's go ahead. Now we will learn about evaporation. You already know what is evaporation. I am giving you some moments. Just try to memorize the definition of evaporation. Yes, you are correct. When the liquid converts to the gaseous form, that process is called evaporation. And here in the figure you can see, in one container some water is kept on the tripod and it is heated, and what comes out that we see in our routine life too, that is vapor, and this process is called evaporation. Now why we are studying this particular phenomena? Because it is there taking place in the surrounding and affecting our life somewhat. Before looking about how evaporation affects us, we will look first the factors which affect the evaporation, and the first among them is an increase in surface area. We will go with the example. Have you ever seen that your mother hangs the clothes without spreading them on the string? Why? For what reason the clothes are spread on the string? What do we do? In fact, when we hang the wet clothes to get them dry, we open them and hang them on the string or on the hanger, we in fact increase the surface area. And this increase in the surface area makes evaporation faster. And since evaporation becomes faster, the clothes get dried faster. The next is an increase of temperature. In the above example, what we have seen, that is surface area is increasing, evaporation is increasing. Here also the same relation is there. An increase in temperature also increases the rate of evaporation. When we leave some water in a pot for some time, it is not getting evaporated fully. But if you heat the same water in a container, means we are increasing the temperature. And since temperature is increased, the evaporation becomes faster and the vessel can become empty within minutes. The next factor which affects evaporation is decrease in humidity. Now what is humidity first? You must have studied about this term in previous classes, but let me remind you. Humidity is amount of water vapor into atmosphere. Humidity is more in the atmosphere during monsoons when it is raining. In the winters it is less. In the summer it is moderate. So when humidity is more into the atmosphere, the evaporation is slower. And when humidity is less into the atmosphere, evaporation is faster. And this can be the reason why, if you have noticed that in the winters, clothes, even though they are not hung in the sun, they get dried faster. The next factor which affects evaporation is wind speed. Many a times in your house it may have happened that your mother might have shouted at you for roaming into the area where it is moved already. And to make the surface dry sooner, what we do is we switch on the fans. And when we switch on the fans, the evaporation becomes faster and the floor gets dried easily sooner. Once again, friends, remember the factors affecting evaporation. You can remember with the words, that is surface area, temperature, humidity and wind speed. Here, three factors are affecting with direct proportion, while one factor is affecting with inverse proportion. Surface area, temperature and wind speed. These three factors, when they increase, evaporation increases. While in case of the last factor, that is humidity, when it is increasing, evaporation is decreasing. That is inverse proportion. Friends, now we are in the last topic of the chapter, that how does evaporation can cause cooling. As we have studied further in the previous video, that how the temperature affects the state of matter. We have studied about latent heat also. What is latent heat? Try to memorize, then I will say. Latent heat is the heat required to change the state of matter. Now, when evaporation takes place, evaporation is change in state of matter. It is the change from liquid to gaseous state. Now, as what we have studied about latent heat, It is the hidden heat which is not appearing to increase the temperature of the material, but it is used up to convert the state of matter. So when evaporation takes place at room temperature, from where does the particles of water get energy? That is heat energy. The heat energy is required for the liquid to convert into gas state. So water particles also require energy, that is heat energy, to convert into gas state. Since we do not provide any heat energy at room temperature, the water particles absorb the heat from the surrounding, and since they absorb the heat from the surrounding, the heat in the atmosphere is decreased, and since it is decreased, what we feel in the surrounding, that is decrease in temperature. Simply what we feel, that is the atmosphere has become cooler than the previous. Now the summer will start, and you can see all around the people are sprinkling water here and there. So what does the water do? In fact, wherever the water is sprinkled, soon after the water starts getting evaporated. During the process of evaporation, the water particles absorb heat from the atmosphere and convert into the gas state. And since these water particles absorb the heat from the atmosphere is reduced, and it makes the atmosphere cool. Friends, we will see some more examples of how evaporation brings cooling. One example is that we wear cotton clothes in the summer, and we perspire also in the summer and not in the winters. What happens? In fact, according to the name of my channel, that is Surprise of God, this is also one surprise from the God. That is the mechanism of our body, that is perspiration, production of sweat. In the summer, whenever sweat comes out of our body, the sweat from the surface of our skin starts getting evaporated. During the process of evaporation, the heat is absorbed, and as soon as the heat is absorbed, what we feel, that is cooling. So during the summer, when our body perspires, when we wear cotton clothes, from the cotton clothes, the sweat which comes out of the skin gets easy evaporation, and so we feel cooling. The cotton clothes can absorb the sweat and not the synthetic clothes. The cotton clothes, when they absorb the sweat, the outer part of the cloth is open to the air and the sweat is evaporated. So when we wear cotton cloth and when our body perspires during the summer, we feel cooling. Friends, you also might have experienced when you take a bottle out of the fridge and you put it on a table. You can see a small puddle of water around it after some time. Even though the bottle is not leaking, where does the water come from? This water comes from the vapor which is there around the bottle. This water vapor is condensed to the liquid form, and this is the inverse phenomena what we have studied in the previous topic, that is evaporation brings cooling while cooling brings condensation. Before going in the last exercise of the chapter, let's revise a bit that What is evaporation? Evaporation is conversion of liquid to the gaseous state by absorbing the heat. And when we talk about it in our daily life, that is evaporation of water. This evaporation brings cooling. What are the factors that affect evaporation? Among them, that is surface area, temperature, humidity and wind speed. When surface area, temperature and wind speed are increased, evaporation is increased, while when humidity is increased, evaporation is decreased. We also have seen the inverse process of evaporation, that is condensation. When heat is absorbed, evaporation takes place, and when temperature is reduced, condensation takes place. And these both phenomena we have seen in our daily life, that is, we feel cooling on perspiration and we see puddle of water around the cool water bottle. And now here you have last in-text exercise. Again, I will remind you that I will just give the hint and you have to try to find out the answers. First question is, why does a desert cooler cool better on a hot dry day? And to answer this question, you should remember the factors affecting evaporation. Second question, how does the water kept in an earthen pot become cool during summer? Here I will give you the hint that you might have seen that water oozes out, that comes out from the small pores of the earthen pot. And there also you should remember one conversion of state of matter, that what we have studied just. Next, why does our palm feel cold when we put some acetone or petrol or perfume on it? Here you should remember the properties of this material, that is what called acetone or petrol or perfume. You might have observed this, that acetone is used as nail remover, petrol and perfume you know well. These three materials get evaporated faster at room temperature. And now you can answer the question. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? So whenever we are served tea, which is very hot in a cup, we pour out the tea into a saucer. There you should remember the factors affecting evaporation and you will get the answer. Last question, what type of clothes should we wear in summer? If we wear synthetic clothes, what may happen? If you answer this question, you will get the type of clothes you need to wear in the summer. Friends, here you have the last exercise of the chapter. Some questions are there. Try to write the answers yourself. The first and second are the conversion questions. In the first question, you have to convert the Kelvin to Celsius, and in the next, you have to convert degree Celsius to Kelvin. You have to remember that shortcut what I taught you. Third question, give reason for the following observations. Naphthalene balls disappear with time without leaving any solid. These naphthalene balls, that what we keep in our cupboards for the clothes to avoid some small insects which may harm our clothes. And you may have never seen any liquid after the balls are disappeared. And you should answer for this question. You can get the answer from conversion of states of matter. Next, we can get the smell of perfume sitting several meters away. Here you should remember the properties of matter. That is how the particles of matter move, they have space or they have force of attraction. Out of these three, what is responsible for the smell of perfume to reach up to us from far? Next, arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, and oxygen. You should first try to find out in which state the water is, in which state the sugar is, in which state the oxygen is. Here, water is in liquid form, sugar is in solid form, and oxygen is in gaseous form. Now, if you remember the properties of the states of matter, you can answer the question about forces of attraction among the particles of water, that among the particles of sugar, and the same among the particles of oxygen. Next, what is the physical state of water at given temperatures? That is at 25 degrees Celsius, at 0 degrees Celsius, and at 100 degrees Celsius. Here also, you should remember the states of matter. Sixth question, give two reasons to justify. First, water at room temperature is a liquid. And the next, an iron almirah is a solid at room temperature. Here you should remember the effect of temperature on the state of matter. Next question, why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Here you should remember the definition of latent heat and you will get the answer. 8 number, what produces more severe burns, boiling water or steam? There also you should remember the latent heat. In the last question, you have to write the names of processes which are denoted by the letters. What comes at A, B, C, D, and E and F. And to get the answer, one diagram is given in the chapter. Go with that. Remember the processes what are called for the conversion from one state to the another. You can get the answer for this all alphabetical letters. Let us conclude. In this chapter, matter in our surrounding, you have studied about the properties of matter, characteristics of particles of matter. You have studied about the conversion of three states of matter. Further, you have studied about effect of temperature and pressure on the interchanging of states of matter. Lastly, you studied about the evaporation, the factors affecting it, and how it is concerned with our routine life. Now friends, during this video or in this chapter, whatever topic, when you go through the textbook, whatever you understand, keep it with you, try to memorize it. Whatever you don't understand, you should write into the comment. You can ask me. If you like this video, just touch the like button. For anything about the video, you can comment in the comment box. I hope now you have enough knowledge about the surrounding, whatever things are there around you. Why some phenomena takes place around you, that is, you may be seeing water drops under the lid when it is covering the vessel, when the puddle of water is appearing around the cool water bottle, how the clothes are getting dried, why LPG is called liquefied petroleum gas and how it is converted to gaseous form. Such all phenomena taking place around you, you might now have got the answer for your curiosity. Thanks for watching video. Have a nice time ahead.